So constraints are going to be built off of the actual pieces themselves. The pieces in question, again, that are being simmed are the proxy ones. So let us make a attribute promote coming out of this proxy thing here. And in particular, I want to get these part attributes because I'm going to use these at the primitive level. Attribute promote basically says take an attribute that was at one level. So if I middle click and hold, you can see the part name is here. They're point attributes, part name and part type. And this says move them to a different level, part name and part type. Now, in the case of packed geometry, there's only one primitive. The packed primitive is represented in space by the one point that it has. So normally you have to worry about the promotion method. If I was going from point to primitive on a polygon, there's many points in one primitive, so you might have to average the values or whatever else you want to do. In our case, because it's just one-to-one, it doesn't matter. You can choose anything and the end result will be the same. So we have them now. Let's also get the name, because we're going to need the names to distinguish the individual pieces once we unpack it. Now, unpacking the proxy geometry is not really a big deal, even with lots of pieces, because they're so simple. They're very simple pieces. Even now, I only have 120,000 primitives. That's not that bad, and you saw how fast that was. The unpack will need to transfer the same attributes, so just copy that, put it here, and now our primitives here still know their names and know where they came from. So I'm going to move this further over here. In fact, we're going to need some space in general, so I'm going to move this up. So first things first, let's start with the concrete. So I'm going to put a blast over here, and I say delete non-selected. Let's do the part type equals concrete. So that's pretty much everything in our example here besides the glass. You might have had wood, you might have had metal or something else, but we often want to take these constraints per material because it's the constraints that really kind of define the feel of the material. Fortunately, there's this connect adjacent pieces node here that does a pretty great job of making constraints. Now, by default, it's set to adjacent pieces from points, and we have a lot of points and whatever, but what I really want to do is adjacent pieces from surface points. Thinks for a second, and now we have this whole nice network. Kind of hard to see, but I think if you move it around enough, you can see the hollow rooms and you can see the windows and things. So what did this do? Adjacent pieces from surface points. Pieces is referring to the individual pieces. A piece is defined usually in Houdini by a name attribute, which is what it says here. So even though these are polygons and primitives, it still knows that that collection of polygon and primitives should be considered a piece because they all share the same name attribute. What it ends up doing is, for example, if I were to say select, and you don't have to do this, but select primitives, so 4, then click this, and then I'm going to choose from it the name attribute. So let's say I found this chunk here. I'm going to press delete. And again, this is just a demonstration, so you don't have to do this. But here we go. This is a piece as far as Houdini is concerned. What it will do, it says points per area. It's going to scatter points for every piece like so. So if I were to say density scale of 100, which is approximately what it's saying, it's throwing points all over it. And these points are storing still the name of it. If I were to tell it to copy that over anyway, output attributes, name. So they still know what piece they came from. And it's going to do this for every single piece in here. And those points are going to search and say, what other points that are not part of my own piece am I the closest to? So if there's another piece next to this one, you can imagine another one, also of a bunch of points, this point might find a point on the adjacent surface of the other piece. And it's going to say, oh, that's within my search radius, make a connection from the piece I represent to that one. And that's what this is doing. So it's finding what pieces are next to it by seeing what do the actual surfaces border. In our previous iteration of this lesson, and in general you still even might want to do, is instead of unpacking this, you can just stick with the original packed pieces themselves and say, you can do adjacent points. I'll do an add here. And you can basically build up our own network from that. Actually, we can just do adjacent pieces from points. And you can see as I increase the search radius, increase the max connections, we're still going to be building up a network because each of the points that we're using is the center of every piece. That's often good enough, and actually the more pieces we have, the better off it'll be. Because the more pieces we have, the closer we're actually converging on the segment of that piece being near the surface anyway. The problem with this method in general is that you might get some errant connections. You might get some pieces that are actually not pushed up against each other, might still think they are because their centers might be close, technically. So all that is to say is you can totally still do this. It'll still work. And it might actually even be better to do this when you have more pieces in your building. But this is always going to be more accurate the way that we did it here. Now, you have a little less control in this method, though, of how many connections you end up with. If I were to artificially reduce the search radius, we'll have less pieces. If I were to artificially move the match search points down, I might lose some pieces. But this is really only reducing pieces in that it's not finding legitimate things to connect to. So probably if you think that, if you're finding that you're getting too many connections and it's really slowing your sim down, I would suggest just deleting these randomly on your own. I don't think we're going to need to do that, but you saw how we deleted some primitives, actually polylines themselves before. You could do something like if some random number generated from the current constraint we're iterating on, because each constraint is a primitive line. If it's less than that, then kill it. So again, you remember, remove prim, the same exact way that we did before. Actually, I'll do 0 this time though. We now literally have 50% less connections than we just had. And you know, the higher we make this, less connections we'll have. So this will make your sim run faster, but now things are not connected to each other that maybe should have been. So don't do that. I mean, we'll just keep it here, I guess, disabled. You'd be surprised how fast it can handle this many connections. When we switch later on to having the higher res piece versions, when there's more pieces, there's going to be more connections. So it will slow it down that way. But it won't slow it down too much, probably, that we need to actually delete any of these connections.